Okay, after a very brief introduction to shell scripting, let's move on to redirection and pipes. So as you can see, today we introduced you many shell tools or the so-called shell utilities. So for Unix or Linux, there is a so-called Unix philosophy. So first, for Linux or Unix, the design philosophy is to write a program that can do one thing and do this very well. For example, as you have seen, there are many utilities on Linux you can use for your work. In addition, there are also other utilities like grep, which can be used to search for pattern or patterns in a file, and then to print out, for example, the matched patterns in this file, or how many matches in this file, or other utilities like SED or AWK. SED is a streaming editor that you can use to filtering your text file. Here you can use SED to replace foo by bar for the entire file. And here you can use AWK to scan and then process this file. For example, here this one single line does a sum of all the numbers from the second column in this file, and then in the end to print it out. So there are many useful utilities for Linux. And then once you have those utilities, you need to make them to work together. And to make them to work together, you can utilize the so-called input, output, and error output stream. Let's take a look here. For example, this is your program. You have standard input, stdin. So basically, this is the input. And this stream is usually labeled as 0 for shell. And this represents the standard input or the input from your keyboard, for example, if you type something. And then the standard output is usually labeled as 1. And normally the standard output goes to the monitor, to your terminal. And 2 indicates standard error. And standard error normally goes to the screen as well. So you can utilize standard input, standard output, standard error, and then to put the output to different files, or even to pass it to the next application for further analysis, for further process. Here I'm showing you the simplest case to use the output of the stream to redirect this to file. In this case, you can use this redirection operator, this greater than operator. So here, this means to redirect the standard output from your application, your program, to this file, my file. And then this will overwrite the original content in my file. Instead of overwriting everything, you can append the content to my file by using double greater than. And then the original content will still be there. And you can also redirect the standard error to a file so that later on you can take a look. The error from your application, you can use this by using the label 2 and then greater than to put it into the standard error. And you can redirect both standard error and standard output by using this slightly lengthy command. So this command means first you redirect the standard output to this file by using this append operator, just a double greater than, and then redirect the standard error to the standard output by using this 2 greater than ampersand 1. So here the label for standard error and standard output are used. As you can see, it's very powerful tool for you to redirect your the output from an application. And also you can use input redirection operator, which is less than operator, to read the input from a file to your application. To demonstrate this, here is a small bash script. And as you can see, this bash script will ask for your input, for example, the first number and then the second number, and then to use read command to read it in and then to calculate the sum of those two numbers. So to do this, you can use bash to run this calculation or to run this script interactively by type your keyboard, for example, type 2 and then type 3, and then you will see the sum is 5. Or you can create an input file with 2 and 3 as input, and then to run bash, and then to put the input to the bash script, and then to let this bash script to run automatically. This is very useful because during this execution, there's no interruption from, let's say, from human keyboard and so on. This can make the execution of this script automatic, which is very useful if you want to make more automatic jobs to let it run on the HPC cluster. And in addition to use redirection, you can also use a pipe operator. This pipe operator is simply a bar, and then to link different commands together so that the output of the first command can be passed as the input to the second command, and then the output from the second command can be used as the input to the third command, and so on. So here I'm showing you one example as command 1, and then through this pipe operator to command 2, and through pipe operator to command 3, and so on. And then you will see this graph shows you the output as input to the next command as output, and then input to the next command. This seems complicated, but the basic idea is very simple. So basically, first, split your task, your entire task for your calculation into smaller steps, and then find out the best utility that can be used to do this small step. And then compose everything together, and then to build up this pipe so that your workflow can run, let's say, automatically. So this is the basic principle. To show you the useful of this pipe, here is one example. For example, after some simulation, you have a file, data.txt with many numbers, 1, 2, 3, 4, I don't know, and then with some values. And then you have your first task to calculate the sum of the second column, but only for the first 20 lines. Sorry, but only for the first 20 lines of the file. And then for this task, you can split this into two subtasks. So the first subtask is, for example, you want to get the first 20 lines of this file, right? The first 20 lines of a file. To do this, you can use head command followed by -n20 to only print out the first 20 lines. And then you want to calculate the sum of the second column. And then you can use AWK, right, to calculate the sum for the second column, which is represented by $2. And for example, you have a new task, and the new task is to find the value in the second column if the value in the first column is, let's say, 42. And then to do that, you first need to think about how to split this task into two or into more subtasks. In this case, first, maybe you want to get the rows with the first column with value 42. To do that, you can use the grab command, this grab command, to grab the text file, and then the pattern that is going to be matched is 42. Here, this character represents the beginning of a line, which normally is the first column, and then followed by space, which normally indicates, the finish or the end of the first column. And then to find out the values in the second column, you can use a cut command. And then the cut command will split rows by using delimiter. Here, use delimiter, the space as a delimiter, and then to only print out the second field by using -F2 to print out the second field. So there are maybe multiple solutions for a problem, but as long as your script works for you and gives you the correct result, and then it's not a problem to use your script here. So as you can see, pipes are very powerful, especially for to automate complicated tasks. And to construct a pipeline, here are our recommendations. First, you need to think about how to decompose your problem into smaller steps, and then to do the tasks step by step for each step, and then check the correctness for individual steps. But during the entire procedure, do not try to make your pipeline as short as possible. So it's better to make your pipeline as longer as possible to make it more readable and to make it more easier, for example, for others to understand. Yeah, this is our recommendation. And last but not least, in this part, for shell scripting and redirection pipeline, we talked a lot. And here again, this is the cheat sheet for you to take it away, to have a summary of what we have learned and talked about in this session.